Hello, my name is Wansan Kim, one of the members of Team E.N.S.O, an acronym of Enjoy New Scientific Ocean. And let me introduce about relationship between E.N.S.O and future climate change. And I will follow this index, introduce about E.N.S.O and E.N.S.O models and how was it changed in the future. And maybe everyone in here already know about E.N.S.O, but I will introduce this very shortly. E.N.S.O is an acronym of El Niño Southern Oscillation, and Southern Oscillation is a large scale of atmospheric pressure change in Pacific Taiki and Dionysian. And El Niño occurred when eastern air pressure was low, so people called E.N.S.O by combining El Niño and Southern Oscillation. And this is E.N.S.O index between 1950 to 2005. We can see, we can know from here, El Niño and La Niña occurred in 2 to 7 years cycle, and El Niño have been stronger and stronger as time passed, and La Niña have been weaker and weaker as time passed. So, we are curious, how was it going in the future? Is in the future El Niño still stronger and La Niña still weaker? So for answer about that, we researched lots of physics, and we were surprised because there were so many physics about E.N.S.O and future climate change, and there are also so many models to predict future E.N.S.O, and all of these individual models were developed for predicting future E.N.S.O, and also all of these models predict different future. Some predict E.N.S.O will be strong, and some predict E.N.S.O will be weaker in the future, and it's because all of those individual models have different simulation abilities and variables. So our team decided to focus only one models, which Korean National Institute of Meteorological Research used, called ECOGS. ECOGS is upgraded version of ECOG, so this considers not only greenhouse gas but also surface aerosol, and this consists of those three things. This is atmospheric model, and this is ocean sea ice model, and this is combined. And ECOGS simulate these four scenarios. 20C3M is an acronym of 20th century climate in coupled models, and which simulate from 1900 to 1999. And B1, A1B, and A2 are future scenarios which apply different CO2 concentration in different CO2 concentration from 2002 to 2099. So let's look about how climate and E.N.S.O are changing in the future by using ECOGS. Before explanation, I will show this in every slide, and I will show you every data in this order: P1, A1B, and A2. So please keep in mind. And these data are mean sea surface temperature anomalies of ECOGS, and this is data of B1 and A1B from 2080 to 1999, and these data are same as this, but the period is different. Maybe I think it is hard to distinguish these numbers, but I think it is not a problem because these two pictures are almost the same. So I think it is okay, just focus on right one. So from this picture, we can know the overall sea surface temperature anomalies are increasing in the future, and sea surface temperature anomalies are increasing as the CO2 concentration increase, and especially in eastern side, the CO2 sea surface temperature anomalies are a little bit more increased, and it looks like El Nino. So Buffers and Liu introduced about this phenomenon. They said many models predict future mean climate will be changed like El Nino state as CO2 concentration increase. It's because subtropical high pressure will be stronger, and because of this, the wind from north to south will be stronger, and wind from east to west will be weaker. And then, because of weaker easterlies, the overland in eastern Pacific will be weaker too. And this picture is wind stress anomalies of ECOGS, and this is B1, A1B, A2. And values in these circles are Binance values, so we can expect easterlies in Eastern Pacific will be weaker. And from the physics, the North Pacific anticyclone will move to polar region, because so the trade wind will be weaker, and it makes the mean climate like El Nino state. So how E.N.S.O amplitude change in the future? This data is a time series analysis data of sea surface temperature anomaly in E.N.S.O region. And this is E1, A1B, and A2, and this contains those three scenarios and compared with 20C3M. So we can figure out from this data the overall SSTA is increasing, and SSTA increase is increasing as CO2 concentration is increased. But regardless of over increase in SSTA, we can see that the interannual variances and decadal oscillations are still exist in the future. And these are frequency distribution of SSTA in the E.N.S.O region. And this is data of B1, A1B, A2. And these are variances from future data to 20C3N. And the center value is 0, and so farther from center, the value will increase. And this right side means El Nino, and this left side means La Nina. So please focus on here. In the future, the strong La Nina and strong El Nino will be weaker, and mean state and weak La Nina will be increase. So let's summary. In the future of ECOGS, the mean climate state will be changed El Nino-like state because of changing atmospheric pressure and weakened estuaries. And in the future, strong La Nina and El Nino will be decreased, so amplitude of E.N.S.O will weaker. But this these are just only one prediction of many models. So and there are so many models, and those individual models have different prediction. So I think we need more studies about those individual models are required to predict future ENSO change.